Good afternoon. Let me introduce myself first. My name is Audrey Hernando. I teach at El Paso Community College, and I'm in the Teachership Academy. In the Teachership Academy, we learn how to teach better, so we're helping our students. And one of the projects that I did through this is the learning outcome utilizing both individual versus collaborative activity-based assignments. I can't stress enough how important education is. Education is everything. It's learning, you learn your objectives, it improves your life. One of the things that it does is it gives you purpose in life. These are people that are going to become doctors. When a doctor becomes a doctor, he's helping the community, or nurses, or scientists, or even a bricklayer. They have a purpose in life. It improves the quality of their life. They have greater resources, so they have a higher quality of life. 9 out of 10 people surveyed said that the education improved their life. And success. Success is one of the main things that happens when you have education. It breaks those bonds or links that you had before you started an education and builds a pathway to your successfulness. I teach biology, and biology is very important, and science is very important to me. So the literacy of the population is important, and I found that there was a 28% of the population is scientifically literate, which means that 72% are not. And the implications of this are seen in our elections. People have to vote for their politicians on the issues that are important to them. So they need to understand the science behind many issues, and they need to understand the science in their life in general. For example, we have electronic devices. We use computers daily, hours sometimes. Cell phones, microwaves, everything in our life is electronic. And one of the questions is, do cell phones cause cancer? That's one issue that science can answer. Medical issues, stem cell research. What do we know about stem cell research? Is it bad? Is it good? What are the implications of it? What are the implications of taking the medications that the doctors give us? Every time you go to the doctor, you get new medications. Can you take them together? Are they approved? What are the results of that? And just understanding your doctor when he gives you results. What is he saying to us? Science can help you with this. Environment, global warming. Is it true? Is it not true? Take science courses. Water quality, our water has a lot of prescription medications in it, so it's important to understand what the science is involved in that. Nuclear waste, where do we store it? Do we store it underground near our homes? If we don't, where is it? Where do we keep the nuclear waste? Dietary issues, what do we eat? How do we stay healthy? That keeps the medical issues down by eating properly, knowing what foods to eat to prevent cancer, the antioxidants. Fast food, is it dangerous? Is it bad for us? Science can answer all these questions. In collaborative learning, it's a technical term for group learning. It's where you take a group of students, put them together to solve problems. One of the most important resources that we ignore as faculty and educators are our students. Our students are able to provide knowledge to the classroom through their individual experiences. It enhances their leadership. They learn to become leaders in collaborative learning. They learn how to communicate better. Decision making. They're able to decide things, make decisions that are properly executed through the education system. Trust building, conflict resolution skills. All these characteristics are characteristics that are important in the job force. Employers want employees that are able to do this. They want someone that can take these, can be the leader, that can make decisions without having to be monitored. So what I did in my study, the purpose of it, was to determine how collaborative learning affected the student learning outcome. My methodology including 4 classes that were utilized at El Paso Community College in the spring 2013 semester. I used 4 sections of classes. 2 were 1406 biology classes. These are the majors: doctors, future nurses, scientists, and 2 sections of biology 1408. And these are the students that are accountants, psychology majors, kinesiology, very diverse group. So I had 2 sets of each. The class lectures were the same for both groups. I lectured traditional lecture in addition to the collaborative assignments for both of the 1406 and both of the 1408. Assignments were identical for the 06 and the 4808. Student age in the classroom ranged from high teens to about early 40s. So there was a wide range of students. My classes, I had 3 of them with 30 students and only 1 class with 29 students. Again, the study period was a spring semester 2013. The only limitation that was really important to me is that I could not measure long-term learning. So here are the results for the general biology 1406. This is the majors course. These are the people that are going to be doctors, nurses, scientists, and so on. The left side of the column is for the individual learners, the students that worked independently. The right side are for the students who work collaboratively. If you look at exam 1, 68.06 for individual versus 70.98 for group learners. Exam 2, 82.66 for the collaborative students, 85.77. It doesn't look like a big difference, but if you're an educator, you know it takes a lot of points to increase an average. Quiz, 71.06. Collaborative, 73.86. Now this is interesting. In the labs, in biology, there is always going to be collaborative learning. Whether they work individual and lecture or work collaboratively lecture. But if you notice, if you look at the score, the average score for individual learners, they had a 90.74 compared to 91.97. Students who worked collaboratively in lecture did better in lab than those who did not. Here are the grades for students enrolled in Introduction to Biology 1408, the non-majors course. The left again is individual, the right again is collaborative students. Exam 1, 76.42 for individual, 77.5 for collaborative students. Exam 2, 79 for individual, 83.94 for the collaborative students. Again, the collaborative grades were higher. I gave quizzes in addition to that. So the quizzes for students who worked individually, it was 81.62 compared to 85.4 for collaborative students. And their labs, again, follows the same trend for as at the majors, 95.51 for students who worked individually in lecture, because they work collaboratively in lab, and 96.64 for the students who work collaboratively in lecture. So collaborative education did help them. So the conclusion showed me that students that work collaboratively had a higher overall average for both majors and non-major biology students. This trend is indicative for both lecture and the lab. Collaborative students outperform students working individually. They have developed improved reasoning skills as evidenced as their lab grades, and they have a positive impact on student learning outcome as indicated by the students' increased achievement levels. So as Dr. Seuss said, you have brains in your head, you have feet in your shoes. You can steer yourself in any direction you choose. That's what we can do. We can take the simple ideas, such as group learning, and apply them to our classroom and get higher grade averages and improve characteristics that they can take to the workforce. And here are my sources. Thank you.